Okay, let's see how you did on the first problem. Okay, we're comparing two relationships, okay, Moki and Kappa. Okay, Moki's weight is shown on a data table, and Kappa's weight is shown on a graph. Okay, first thing they ask, which panda was heavier when they were born? Okay, so for Moki, that's going to be how much Moki weighed at 0 weeks. So Moki initial weight was 1 pound. Okay, the initial weight for Kappa, okay, when you have a graph, the initial amount is where the line crosses the y-axis because that shows you 0 weeks or months or seconds or whatever the problem is. So at 0 weeks, Kappa is 2 pounds. Put it right there. Okay, so which panda was heavier when they were born? It'd be Kappa. Kappa, because Kappa was 2 pounds and Moki was 1 pound. Okay, which panda is growing faster? Well, if you look at Moki, 1 week goes by and Moki has grown 4 pounds. Okay, another week goes by and Moki has grown another 4 pounds. Okay, so Moki is growing 4 pounds every week. Okay, that's the slope, guys. Changes the slope. Okay, Kappa's growth, just pick any 2 points and do rise over run. Rise over run. So I'm just going to use these 2 points here because they're nice corner points. Okay, we're going up. Now, be careful. It looks like we're going up 3 pounds over 2 weeks. Okay, but notice the pounds, the y-axis, it's counting by twos. Okay, did you notice that? It's counting by twos. So the rise would be up 6 pounds. The run would be over 2 weeks. Okay, so the change for Kappa would be 6 pounds over 2 weeks would be 3 pounds a week. Okay, so let's see. Moki is growing 4 pounds a week, and Kappa is growing 3 pounds a week. So Moki is growing faster. Okay, which panda will weigh more after 5 weeks? Okay, guys, you could use the patterns. You could like extend the numbers in the data table and the graph, but I want to show you something because it'll help you on the other problems. If you want to know which panda will weigh more at 5 weeks, you could first work with your equation. You may not have thought to do it this way, but the equation, okay, instead of P, we're using P for pounds, and instead of X, we're using W for weeks. So Moki's equation, P equals slope W plus y-intercept. Okay, the slope for Moki was 4, and the y-intercept was 1. So P equals 4W plus 1. Okay, for Kappa, let's see, the slope was 3 pounds a week. The y-intercept was 2. So his equation would be P equals 4W plus 2. Okay, the slope goes in front of the variable. The initial amount goes at the end. Okay, now let's look at question 3. Okay, which panda weighs more after 5 weeks? Okay, so for Moki, here's a trick. P equals 4W times 4W plus 1. Okay, W stands for weeks. So if I want to know Moki's pounds at 5 weeks, I'm just going to replace W with 5. So Moki is going to be 4 times 5 plus 1 pounds. Just be sure to multiply first. So Moki is going to be 21 pounds after 5 weeks. Okay, Kappa, his equation is P pounds equals 4 times the number of weeks. I copied that wrong. His is pounds P equals 3 times W weeks plus 2. So just replace W with the number of weeks they're asking about. They're asking about 5 weeks. So P equals 3 times 5 plus 2. Multiply first. 3 times 5 is 15, plus 2 is 17. Okay, so Moki weighs 21 pounds after 5 weeks, and Kappa weighs 17 pounds after 5 weeks. So Moki would be heavier. Okay, and again, you could have used the patterns. You could have just extended the data table. Went up a week, went up a week, went up 4, went up 4. Okay, but it's easier if you take the equation and put the number that they give you, weeks, put it in for the variable, W, and then solve for the other variable. It's just a lot simpler. Guys, let me know how you do on the rest of the problems. Keep me posted if you need any help.